will need some help.
Right now? What's up?
I mean, right now. I got some.
But see here, see how there's still a Y? Take a Y out also. This is GCF also. See what do we want? Yeah, it can come out. And then this is going to be 5 times negative 6. Right, because the first number is not a 1. Actually, negative 30 make negative 1. Yeah. Well, no, I know. It's because I do it all the time. That's the only reason it's right there for me, you know? I'm going to sort of start to do these just to catch up to you. So you can write it like that if you want to, not equal to. The only time you would write that is if it's on the bottom. So you're saying, I can't use 2. That's what you're really saying. X can't be 2. That's what that says. They say not equal to. Consistent. So 2A, the very first thing you do top and bottom are GCF. Don't forget GCF. If you're like, I don't know what to do, go, let's try GCF, because maybe that's in the way. This can reduce, let's go ahead and do that. This will be a little bit big, dude. Yeah, so it'll be M, so M plus 3. You got the 2 M's, you got the 2 3's. Die! That always feels good. Kill the whole thing. And what's left alive? Well, what did I forget? I forgot my 2. So what's left alive? M plus 3 over 2. Part of this should be kind of satisfying. You're killing these things. And you're whittling it down. Yes, sometimes to nothing. If everything canceled, what would the answer be? 1. Good, beautiful. Because you're dividing things by themselves, your answer would be 1, not 0. I like to do that sometimes. Give you one where everything cancels. Don't say 0. Oh yeah, 2B. All right. Well, not to B. Let's see. So that's nice. It's the GCF. The bottom there starts off as just a GCF. This bottom here is a GCF. Now watch this. I don't know if you guys remember the little shortcut I told you about. I'll bet you anything that this top has got a 5a minus 6b. Am I certain? No. But if it did, what would this have to be so that it comes out to be 5a squared? It'd have to be a minus 6b squared, so it'd have to be plus b. And then I get negative 6ab plus 5ab is negative ab. So it gets the middle term. It works. Now, did you have to do it that way? No, you could have done 5 times negative 6 is negative 30. Factors of that to make negative 1. Split the middle term. But I've got a hint in the problem. The more you understand, the less you have to do. What's the last thing I can do something with? I'm not done factoring, right? I can kill those. Yeah, this can be factored further. And what I over here. I got a plus b over 2. So then 2 goes into 6 3 times. So I got 3y over a. Bam. So part of the problem with these is just organizing it so you don't leave anybody. You make sure you get all your survivors down here. Don't leave anybody back here, surrounded by zombies of dead pieces. Get them out of there. Watch too many movies. Oh, hopefully everybody had that. I don't hear anybody yelling. And then 3 is the relatively new stuff, right? What can I do with 3a? Okay, so I can add them together. And again, what's the last thing you always try? See if it reduces. So in this case, it is a GCF of top. And then what happens? Yeah, the 2x plus 1s. So no matter what x is, the answer is 6. And then part B, just to cut to the chase, is this only got a minus? Oh, I love it. Okay, so let's focus on this. This is the part. Okay. Yeah. When you put these together, I'm going to make a mistake. Here's a mistake. I have made a mistake. That is a mistake. Go write that and circle it and say, my teacher said this. That is wrong. What have I done wrong? Does anybody see what I've done wrong so far? No, that's what I'm going to do next. But I haven't gotten there yet. I've already made a mistake. Yes, this is so weird. When you write like x plus 1 over 2, how do I write that in a straight line, like divided by 2? What would I put here? If you just put this, you're wrong. Do you see why you're wrong? This is x plus 1/2. Is that what that is? So what do I really mean here? What's being divided by 2? Oh, shit. This whole thing. So that long-ass division bar is actually evil. We so easily forget that everything is naturally in parentheses everywhere. We don't have to write them because that's what the division bar does for me. I know the top and the bottom. I can see them. I don't need those until I start doing shit like this. So what am I supposed to do with this negative? Go to both. This should be a -4. Damn. Damn you negatives. So it's those understood parentheses that we... What happened?
It came out the wrong. Well, the way you.
Damn you negatives?
Oh.
I thought that you did.
The ER.
Oh, I said.
Yeah.
All right. No. I said negatives. Don't get me in trouble. I don't want it. That's funny.
You might have to edit that one out.
Dante. Stop. Oh, God. Stop it. You ever see...
I'm sorry.
Huh? That's all right. That's all right. All right. So now that we're past that, does everybody see the idea there? I love it.
You don't want to take the one?
No, I'm never going to say that word again now. You know those not positive things? All right. So you're going to have to remind yourself, just remember when there's a minus in a problem, you know it's going to give us trouble when there's a minus in the problem. So this is another situation. There's a minus in there. I have to be careful about it. What am I subtracting? Everything over here. Minus everything. Not just minus x squared, it's minus the whole thing. Okay, I like it. And then what do you get here? Now I can get my like terms together. X squared. And of course, what happens there? Yep. So the top is just squares. I can't get over that. I'm so happy you reacted by laughing instead of like coming up here and kicking my ass. Okay. So that's the worst part of this, right? If the bottoms are the same, the only problem you could really have is if there is a minus sign.
You just have to distribute it.
Yes, you just got to remember to distribute that. It's minus this whole thing. So they both should become opposite signs. Seriously, I'm not going to say that word. It's going to be a problem for me in my profession. Let me see, what was the other thing? Oh, let's do one little example of what's coming next. So watch this. This is kind of nifty. I don't think I've done this with you guys yet. Let's see. Let's do, yeah, I like it. Sure, we'll do this. So this is kind of a gross fraction problem. Dear God, if anybody puts the answer as 18 over 93, this is a major problem. Right, the reaction I have, no, please, if somebody out there believes this is the answer, where did that come from? Just adding everything. So this is saying, though, do you see, I want you to really understand, this is saying that I have 18 93rds. Do you see any 93rds there? I don't see any of them. How did you get 18 of them? So that's why I need like denominators, so I can consolidate how many of those things I've got. These are ugly numbers. Can somebody tell me what's the biggest number they have in common? 3. So 60 is 3 times 20, and 33 is 3 times. Now watch how that makes this so easy. What is the first dude missing that the second dude has on the bottom? What's he missing? What's he missing that he's got? An 11. Give him an 11. What's he missing that he's got? 20. So you give him 20. Do they have the same denominator now? Yes, whatever it is. Right? It's 60 times 11, which is 660. So I get, what's 11 times 11? 121 over 660 plus 140 over 660 is 261 over 660. I can't remember if I've shown you that yet or not. If you identify the largest number that goes into both, and then you write them each in terms of it, you can just give them what they're missing. Because what's the whole idea of LCD? Build them both up until they're the same. So you can see what they both already have. You can see what they need to become the same. It's crazy. I used to always joke, it's like two kids. Oh, you got sprinkles. I didn't get sprinkles. Here's some sprinkles. You got more sprinkles. Just give me, just eat the whole ice cream. Nobody gets any ice cream. It's probably better not have kids. So how does that work? Here's one example of how that works with what we're doing now, because we don't have nice numbers now. We have these kind of unknown numbers. So what if I had 7 over x squared minus 1 plus 2 over, what do you got, Jeff? X plus 1. I like it. Now which bottom can you break up? Yeah, so see how, again, it's all about factoring. How do you factor x squared minus 1? So who's missing something that the other one's got? This guy is missing an x minus 1, so what are you going to do? Now be careful. Do you see how I have to do it to the top and the bottom? That's what makes it legal. You can't just give them the bottom, just make the bottom change and leave the top the same. You've totally changed the problem then. You've got to do it top and bottom. You know this. So then what do I end up with? 7 plus 2x minus 2 all over. Yeah. So then I get 7 minus 2 is 5 plus 2x. Get out of there. Can you reduce that? Does anything factor on the top? Does the top factor? No, it's 5 plus 2x. So you're done. Not that bad. And again, the same thing with all of chapter 7. The better you are at factoring, the easier these problems will be. Every section in chapter 7, I've said that so far. So if you still aren't good with factoring, that's what you want to focus on. That and negatives. Okay. All right, I think that's enough. That's enough. Oh, real quick, before I forget, what is today? Today is Tuesday.
Yeah.
Let's have a quiz on Thursday. It's going to have cubes and 7172. Let's just make it 7172 because that's going to have everything, all the factoring on there. Thursday. That's the test. Next Thursday.
Next Thursday will be the test.
Yes, I'm pretty sure. It's on the homework sheet. Oh man.
I got you. Here are my quiz corrections.
The quiz is
Thanks, man. Oh man. That's all I need.